Okay, so for this problem, they are already giving us is the a matrix, and they have already solved for the eigenvalues. So we just need to find the eigenvectors. For question A, they are asking me for the eigenvector that has a corresponding eigenvalue of 1. So what they are asking me for in this question, they are asking me for the vector x, that it's, like xy, such that m of x equals to 1 times x. O sea, they are asking me for the eigenvector x comma y, so such that 0.2, 0.8 times 0.7, 0.3 times x comma y equals xy. Okay, so from here, I can set a system of linear equations. So that would be 0.2x plus 0.7y equals x, 0.8x plus 0.3y equals y. And so we're gonna lean solve the system. I'm gonna add a calculator. In this calculator, I'm gonna add an algebra. I a menu algebra solve system of linear equations. I have two equations with two variables called x and y. And so it is 0.2x. I'm gonna put times x plus 0.7 times y equals x, and 0.8x plus 0.3y equals y. I am missing this times. Okay, so my eigenvector, according to this, is the eigenvector 0.875 C1 C1. No, and remember that is whenever we have whenever we solve for an eigenvector in the calculator, is that we have more than one answer, no? Is that we have an infinite amount of answers, no? Is that this C1 could be any constant. And the calculator gives me C1 or C2 or C67 because it is counting how many times I have done this, no? So usually we do c1 equals to 1, no? So usually my answer would be 0.875 comma 1. Ah, but look at what the question is telling me. The question is asking me to write it as an a comma b such that a and b are whole numbers. So I just need to multiply by something such that this vector is a vector in which both entrances are whole numbers. So, o sea, I want this and this to be whole numbers. So I'm gonna do. What about if I multiply it times 1,000? If I multiply it by 1,000, it would be 875 comma 1,000. And that would be a way of solving it. Okay, and now for part B, so they are asking me for the long-term probability. So the long-term probability is another name for the steady state. The steady state. So a way of finding it. Remember that the steady state is so you graph your matrix, your transition matrix, and you will make it. O sea, you want to find a what is the power of this matrix to a very long, o sea, to a very high exponent, no? O sea, like this should be like a high number. So a way of doing this, we can. create a matrix, menu, a matrix and vector. I menu, matrix and vector, create a matrix, a 2 by 2. Our matrix is 0.2, 0.7, 0.3, and 0.8. And that to the power of a very large exponent. Now, is the, let's say, 50. So look, this column and this column, o sea, this column is my steady state, ¿no? O sea, like the vector, the vector 0.466 and the vector 0. O sea, 533. O sea, the vector 0.466, 0.533. This is a steady state. Okay, but look, here we have a little problem because my calculator is giving me this number as a decimal, and look at how the question is asking me for a look at how the question is asking me for the answer. So, do you agree that, for example, this one is the probability of going to A, like in the long term, and this one is the probability of going to B in the long term? So, the only complicated thing that we should be doing right now is turning, 0.466 into a fraction, no? But I think that that is not that hard, no? So I don't know, like a way of doing it could be like, for example, uh, this is the same as, um, o sea, this is the same as if I multiply times 10, o sea, 0.46 times 10, no, is the same as 4.6. And do you agree that this is the same as 4 wholes plus 2/3? No? So that means that 4 wholes plus 2/3 divided by 10 is the same as 0.46. O sea, this is 4 times, so this is 15/3 divided by 10. O sea, this is 15. 3 por 4, 12. Ah, this is 14. Sorry. This is 14. 30s. O sea, it is the same as 7/15. Whew. So look, this is 2 marks. If you wouldn't have been able to write it as a fraction, that would have been 1 out of 2 marks.